converting.
Wait, no, condensing and expanding logarithms.
Okay. So an example. Just tell me one question that will try solving.
Uh, I can have a practice.
Okay. Okay. Sure. So now since we are connected, what I did was I went through the syllabus for what I sent you, right? What
Yes.
will be learning in the class. But if there's anything that you want me to kind of prepare for, I mean just make sure that I cover the entire thing, right? Otherwise I'll just tell you what I recall at run time. So just use that Telegram channel or WhatsApp, whatever is comfortable with you, to send me a message saying, Uncle, I need this one. So I'll make sure that I prepare for that before the class. Okay. Yeah. Tell me. Let's see if I can teach you right away, or else I'll explain that to you in tomorrow's class.
Like this question. Question 7.
Okay. So it says expanding and condensing logarithms. Expand each logarithm, justify each step by stating logarithm properties. Okay. And this is log 4x cube. Okay. Can you do one thing? Can you send this question to me?
Yes.
I will get all of these solved in the way that you guys understand, or that the way you learn here. I don't want to teach you the Indian way and then you'll get worried about how do I answer that. So attach that PDF. Okay, you have sent it to me. Alright. Okay. So you need all of this to be explained? You want all of these to be explained in the next class, or just the concept level thing?
The concept of it.
Okay. Okay. And here you have the answers as well.
Yeah.
Okay. So let me attempt one of those to see if I'm able to explain that the way you guys. No. Okay. Let me go through the syllabus for you guys, and then in tomorrow's class I'll make sure that both the things, right? You have expanding logarithms and condensing logarithms both. This will cover tomorrow's class. Okay. Because some of the things I would have learned 30 years ago. So I have to kind of brush it up, make sure that I cover all the different aspects, and then we'll come to that. Alright. Alright. So let's continue from where we had left in the last class. Right? We had started the foundational algebra, where we talked about linear equations, we talked about standard form, y-intercept form, slope-intercept form, and then we also tried solving some other equations. Yeah? Are you recording it? Yes. So, if somebody gives an equation like 4x plus 3y equal to 7, if you have to convert that into standard form, it will become standard form. When you say it's like ax plus by plus c equals 0, this is a standard form. You convert it in this format. So what you will do, you will bring this guy to this side of equal to sign, make sure that you have a 0 on the other side of equal to. So this becomes 4x plus 3y minus 7 equals 0. So this is a standard form where a is 4, b is 3 and c is minus 7. Yeah. Now if the same equation you have to convert into y-intercept form, slope-intercept form, what you will do, you will keep y on one side and move everything to the other side. So this becomes minus 4x plus 7.
Yeah.
And then y, your slope intercept form goes like y equal to mx plus b or c, whatever you call it. So here this becomes 7, which will further explode into 4x by 7 plus 7 by 4. What did I do? By 3 plus 7 by 3.
Yeah.
So this minus 4 by 3 is your slope and this is your intercept. This part is clear, right? Now you tell me what are the things that I mentioned in the chat today. Let's look at that.
Linear equation word problems and then graph of linear
Okay.
systems and inequalities.
I will do one thing. I'll just pause this video, run and come back in a minute.
I was supposed to take a printout.
Question
Exclude this part from here.
Already harvest of these kinds of honey from her bee colony. If she wants to package the honey harvest in pound jars, what is the minimum number of jars she can fill?
Okay. So basically, these are the word problems that we end up dealing with as part of SAT preparation actually. And this is one of the most common segment of the questions that you'll end up dealing with. So we'll use the same formula tram. Read the question once. Or you can harvest at least pounds of honey from her bee colony. So at least pounds. Okay, let it be. If she wants to package the honey harvest in pound jars, what is the minimum number of jars she can? Okay. What is the minimum number of jars she can fill? This is an interesting question. Let's read it. I'm not clear yet. Or you can harvest at least pounds of honey from her bee colony. So pounds of honey, okay. If she wants to package the honey harvest in pound jar, what is the minimum number of jars she can fill?
Let's say this is a
Jar. If in pound jar,
so every jar is
1 pound. What is the minimum number of jars she can fill? What is that meaning you are getting from this question actually, if you read it a couple of times? She can at least pounds of honey. So at least pounds. So it has to be in pounds. Nothing less than a pound. The minimum that you can think of is 1 pound. If she wants to package the honey harvest in pound jars, what is the minimum number of jars she can fill? 1. Yeah. So, I mean, it looks cryptic, but when you read it a couple of times, right, it has to be pound jars. And what is the minimum she can fill? 1. Okay, let's look at the second one. Brian wants to make for his friends. Is it something that I have not printed? Brian wants to make for his friends. The snack is made by inserting a peppermint stick into the middle of a pickle. The peppermint stick cost I did something. It seems that the numbers are not printed correctly here. Okay, let's go to the back. This one, last 2 questions. Okay, you flip the page. That one is a complete question at least. I did not notice that the numbers are not printed. I think that's what is leading to this problem. Okay, in first one also some numbers were missing. That's why all 3 questions, right? The numbers are missing. Okay, I should have taken a screen print rather than copying it. Okay, let's solve these 2 problems. One problem first, then we'll go to the next topic. Christian's goal is to walk an average of 50 kilometers a week for 4 weeks. Okay, is to walk an average of 50 kilometers per week.
50 kilometers per week.
Okay, I'm just noting it down.
For 4 weeks. So
Christian's goal is to walk an average of 50 kilometers a week for 4 weeks. So he's going to walk for 4 weeks, and minimum or the average is 50 kilometers per week. He walked 56 kilometers for the first week. So this is the average that we're talking about. Yeah. He walked 56 kilometers for the first week.
So I will do it in the simplest possible way. So we are talking about 4 weeks. Okay.
So first week he walked 56 kilometers. 52 kilometers
The second week. Okay.
and 38 kilometers in the third week. Which inequality can be used to represent the number of kilometers X Christian could walk in the fourth week to meet his goal? So again, I'm reading the question again. So this is trying to derive a linear equation from the information that we have, and that's what you have 4 answers here. You have to choose which one is the correct one. So I'm reading the question again. Christian's goal is to walk an average of 50 kilometers a week for 4 weeks. Average of 50 kilometers per week for 4 weeks. He walked 56 kilometers in the first week, 52 in the second week, 53 in the 38 in the third week. Which inequality can be used to represent the number of kilometers X Christian could walk in the fourth week to meet his goal?
Here if I look at this, so it is like 50 kilometers per week, 4 weeks he is going to walk. So total kilometers he is going to walk is 200 kilometers.
Now, they are trying to represent this in the form of equation. Let's look at this one. First one, what does it say? 56 plus 52 plus 38 plus x is greater than 50. Greater than or equal to 50. Does that look right? No, it is not. Next one is 56 by 4 plus 52 by 4 plus 38 by 4 plus x is greater than or equal to 50.
Okay, now based on whatever we have seen here, let's
First try putting our understanding.
we'll come to this. So first week is 56, second week is 52, third week is 38, plus fourth week there is something.
Okay.
And this is supposed to be equal to how much?
No. This is. Let me read the question one more time. Christian's goal is to walk an average of 50 kilometers a week for 4 weeks. Average of 50 kilometers a week for 4 weeks.
So if I take 4 weeks
Average, that has to be 50 kilometers.
so if you sum it up and then divide by 4, that has to be
50. Okay. His goal is to walk an average of this much.
so to me it looks to be, he's not saying it has to be exact 50.
His goal is to be this much. It could be more than that also, right? Now let's look at the equation.
The first one is anyways this plus this plus this plus
X is greater than or equal to 50.
is not correct.
First one is not right. How about the second one?
Yes. But it didn't divide the x
Yeah.
by 4.
Yeah. So this is
Here if you explore this, it becomes 56 by 4 plus 52 by 4 plus 38 by 4 plus x by 4. This has to be greater than or equal to 50.
so second one is not the right answer as well. How about the third one? Third one is nowhere close to being correct, right? The fourth one is again not printed correctly. The last line is not printed correctly.
So it is actually the answer, as I correctly remember, it is 58, 56 plus 52 plus 38 plus x by 4 is greater than or equal to 50.
So that the denominator part is not printed correctly. That is what is causing this problem. Because if you look at the last letter, right,
Yeah.
is saying greater than or equal to 50. That denominator part is not printed correctly. That's a mistake on my part. I will fix it. Okay. Now,
So
First, second, third is not the right option, fourth one is the answer. And if you look at this one, this whole question, if you see, right, we have done nothing as such here. We have just read it a couple of times and we have just converted that into whatever is our understanding. So, any linear equation that you deal with, it will be simple English that you have to read, and then interpret, or do some rough work. And then when you try relating that, you'll be able to get to the this thing. Let's try the last one. Next time I need to do a better job with respect to printing the questions so that it doesn't misguide you. Let's read the next one. A cargo van delivers only 50 pounds and 80 pound packages. A cargo van delivers only 50 pound and 80 pound packages. So, in the cargo van, the packages that are there are either 50 pound or 80 pound size. There are only two type of boxes in the van. Yeah? For each delivery trip, the van must carry at least 20 packages. So they are 50 pound packages like the cartons, or the 80 pound packages. Second type of carton. Yeah? For each delivery trip, the van must carry at least 20 packages, and the total weight of the packages cannot exceed 1500 pounds. Okay, this is a good one. At least the question is correct. What is the maximum number of 80 pound packages that the van can carry per trip? Okay, let me make you think. Tell me, are you able to understand this question?
Yes.
Are you able to solve it also? Okay.
Yeah,
Okay, try it. Let's see. Let's validate that. So now I am becoming a student for next 5 minutes. Okay, meaning when I am trying to do this sum, right? If it's not you who is doing it, if it's me doing it, this is what I am going to do. A cargo van delivers only 50 pound and 80 pound packages.
Okay, so there are two types of packages. One box, another type of box. This is 50 pound, and this is 80 pound boxes. Okay.
Yeah. For each delivery trip, the van must carry at least
20 packages. So there are some packages here, there are some packages here,
of this side.
this size.
And says for each delivery trip, the van must carry at least 20 packages.
So this plus this has to be at least 20.
It can be more than that, but it cannot be less than that. The van cannot go empty. And the total weight of the packages cannot exceed 1500 pounds.
So some number of this, this many boxes of 50 pounds plus this many boxes of 80 pounds cannot weigh. Weight of one box will be 50 pounds. Let's say I have X boxes. So it will be 15 to X, this much pound with these 50 pound boxes. And if I have Y number of boxes
With 80 pounds,
so every box is 80 pounds. If I have Y number of boxes, so X 18 to Y, if I add them together, that is going to be the total weight of that the van is carrying. It says the total weight of the packages cannot exceed 1500 pounds. so this has to be less than or equal to 1500.
Yeah.
Now, so you are saying that there are two equations that we got, X plus Y. So X is the number of boxes which are 50 pound in weight, Y the number of boxes in the 80 pound weight. This together has to be more than
Or equal to 20.
and whatever be the number of boxes, the total weight
Has to be less than 1500 pounds. That is what you would have done so far, right?
Yeah.
This is the same approach. So basically what we have got is X plus Y is greater than or equal to 20 and 50X plus 80Y is less than or equal to 1500.
Now it says, what is the maximum number of 80-pound packages that the van can carry per trip? What is the maximum number of packages
that the van can carry per trip? There could be a situation where the van is carrying
only the 80-pound boxes or only the 50-pound boxes also? Those are also possible situations, right?
Now,
Let's assume that you have only 80-pound boxes. What will happen then?
Then you have to calculate 80x.
80y
Yeah, 80y.
equals is less than equal to 1500. Now 80, okay. So basically y has to be less than equal to 1500 divided by 80. This is 150, okay. I'll say 75 divided by 4.
Yeah?
So 150 I can write as 75 into 2 and 8 I can write as 4 into 2 and I do tic-tac-toe.
Yeah?
So 75 by 4 is what? It's 18.375. So basically the number of boxes, this number of boxes of 80 pound has to be less than equal to 75 by 4. So it has to be less than
18.75. And you said 18. So you did the right thing. That's how you said
it
it.
has to be less than this. So if it is 18.65, that is also correct
Because
because
it is less than this one. But you will not have partial boxes. You will have full number of boxes. That's why you found the nearest or the highest whole number
next to this one.
lesser than this is 18. That's how you got the answer. Right?
So there are two ways of solving it.
We took the shortcut actually. He said, okay, fine. My van can carry both the types of boxes, but it can. Nobody is telling me that it has to carry both the types. Right?
So
You got the right answer.
I'm not trying to solve this equation.
But
In case you end up solving this equation, okay? When you have inequalities, this is what is called inequalities, right? Where you, okay, let me write it down. If you had an equation like this, 50x plus 80y equal to 1500.
this was a normal equation.
Or equality, whatever you call it. Since it was giving us a condition not equal to, it was not say, it was saying not equal to.
Okay, one second. Okay. Are we going wrong here? Actually, we are going wrong.
See, if you look at the first equation,
For each trip, the van must carry
At least.
at least 20 boxes.
So it should
So-
be greater than.
So,
if we go with only y,
meaning only 80-pound boxes.
Oh, it will be less than 20.
Yeah? So it will be less than 20.
But the answer choices don't have anything above 20.
So it says maximum number of boxes.
so this is not the maximum number of boxes. So to make sure that you meet both the criteria, this and this,
The number of boxes will be lesser than 18.
because if you go with 18, then it meets only this criteria and makes this condition fail.
So 18 is not the right answer. Yeah? So I was proven wrong.
Right? That's what I was thinking. And that's what anybody would think. So, here's the solution now. Okay? So, good that we did not conclude in the wrong way. Now, the equation is this. And second equation is 50x plus 80y is less than equal to 1500.
Okay?
Now,
So 18 is ruled out. 18 is out of equation now. If you have an equation like this to solve,
what you always end up doing is you look at the situation which is equal to,
and then you will put the condition in that equation.
to get the answer. So this has two parts, less than or equal to. This has greater than equal to. Let's go with the
Equal to sign, that's what I was coming to.
that in any situation like this, when you have two inequalities to use for solving the equation, you'll go with the equal to situation. So let's find out the value of x here. X will be 20 minus 1.
Yeah.
Now, or let's not do that. So okay, fine. Let's continue with the whole thing. X plus y is greater than or equal to 20, and this is less than or equal to 1500. So here I will treat this as equal to and do the limits. So what it says is x has to be greater than or equal to 20 minus 1.
Fine.
I'm treating this as a
Equal to sign.
and playing with it.
It goes the same way, okay?
You'll use this inequality as the borderline and
Move things the way you move with the equal to.
so if x plus y is greater than 20, that means x is greater than 20 minus y.
That is how it will be.
Now let's put this value in here. X is greater than 20 minus y. Okay, so instead of x, let me put 20 minus y. Twenty minus y into 50 here plus 80y is less than or equal to 1500. So this becomes 20 into 50,000 minus 50y plus 80y less than or equal to 1500. Okay, so this becomes 30y plus 1000 is less than or equal to 1500. Yeah,
Am I?
so I'm just using this as equal to sign. Okay, I got the value of x from this one. X says that it has to be greater than 20 minus y. Okay, so I substituted the value of x in this equation, 20 minus y.
Okay.
What did I get? 20 minus y into 50 plus 80y. I'm just splitting that. 20 into 50 is 1000 minus 50y plus 80y.
Yeah.
So this becomes 50y negative plus 80y positive, that is 30y plus 1000 is less than or equal to 1500. So 30y is less than or equal to 1500
Minus.
yeah. So 30y is less than or equal to 500.
Yeah.
Divided by 30.
Yes. Y 500 by 30. So this y has to be less than equal to 50 by 500 by 30. This becomes 17. So y has to be less than equal to 17. Now, when y is less than equal to, now let's put this value. Y is less than 50 by 30, 17. It is 16 point something. So what we got is y is less than equal to 50 by 3. So y is less than equal to 16 3 are 48, 16.66. So it has to be less than 16.
So y's value has to be always less than 16. That's what this equation says now.
So here
Y's value has to be less than 16.66. So the nearest value that you have is
16. 16. Let's put that value 16 here and see what happens. Okay. So if I have y as less than 16, less than 16.66, any value less than this
Might be suitable for this one.
So now if I put 16.66 or let's say 16, what happens? Y is 16, so x plus 16 is greater than or equal to 20. X is 20 minus 16. X has to be greater than 4. Okay. So now that means greater than or equal to 4. So if it is 4 is number of 50-pound boxes and 16 is the 80-pound boxes. Let's see whether it's
Meeting this criteria or not.
this is 200 and 16 into 8. 16 8 1. 16 8 148. Yeah, correct.
Yeah,
So if you add this and this together,
it is.
it is not meeting this criteria now.
Yeah.
And the reason being, we have done a mistake. That mistake is when we were doing this calculation, x plus y is greater than or equal to 20.
And we were doing this.
What did we do is x has to be greater than or equal to 20 minus y.
Okay.
So 20 minus y has to be less than or equal to x. That is how we could have put it. So we have, what we have done is, here the value of x is greater than this value and we have put this as is, as equal to. That is what is making it go wrong. So in such a scenario, what you have to do is, this equation,
Let me think how to explain this to you.
okay. Here we are saying x is greater than equal to 20 minus y. So I will put, if I am substituting the value of x here, what happens is I am looking at the value of x. Okay, yeah, got it. Yeah. So let's look at it with a different approach. X plus y is greater than or equal to 20 and 50x plus 80y is less than or equal to 1500. Okay, yeah. So here, when we are looking at this situation, right, we'll always calculate it like, we'll pick up the situation which is equal to part. Okay, yeah. So here value of x is 20 minus y, and this is the best case scenario. I mean, x has to be always greater than this, but we are picking up the only solution which is kind of equal to. So you have to pick up the equal to put that in the equation. So from this one you get y is less than equal to 16 point whatever we got, right, 75 whatever. So when you are substituting this value, when y is less than this, meaning we are putting 16, so x plus 16 has to be greater than or equal to 20. So x has to be greater than or equal to 4. Okay, yeah. So, okay. Yeah.
Now I can probably connect the dots and explain this.
Take a break.
Take a break so that we don't keep on repeating the same thing. So these are two equations. It says if I have
Total number of boxes, 50 pound plus 18 pound, has to be greater than or equal to 20.
okay,
It has to be greater than or equal to 20. Now, and the total weight that it can carry has to be less than or equal to 1500. Okay? So, you get the value for both the equal to sign. Okay? X plus y equal to 20 and 50x plus 80y equal to 1500. Now play with this.
I think that will get the right answer.
Because there is one scenario when it's equal to 1500, there is one scenario when it's equal to 20. Okay. Now, from this one, you get 20 minus y equals x. Put it here, 50 into 20 minus y plus 80y equal to 1500. Now this becomes y equals, okay, so going step by step, this becomes 1000 minus 50y plus 80y equal to 1500. So this 30y equal to 500 by 500. So y equals to 50 by 3. 500 by 30, so that is 50 by 3. So y equals 16.66. Now, this is the borderline case, meaning where y is 16, basically 16.66. So I'm just taking the rounded number, so that is 16. It has to be less than this, right? Because if it's 16, now put this. Now let's say you got this value 16.66 or whatever it is, right? Now put this value here. If you put y 6, so you have to either use 16. If you use 16 here, what happens? It's 16 plus 4. And you use this one, what is the value that you are getting here? Put this 15 into 16, y 16. So 16 into 80 plus 4 into 50. This gives us a number
Higher than this, right? This is
128. Yeah, I was doing something wrong. That's why I was. Yeah.
128.
16 8 is 128. So 1280 plus 200.
yeah. This is fitting the bill. That's why I was
wondering what is that I'm doing wrong. So if the teacher is not in practice, that means there could be something wrong. Now we got it. Okay. Simple approach. Forget about the solution part. Okay? And then I will tell the approach, and then again we'll solve it. And then we'll see what is happening here. So whenever you have this kind of situation, you only use this inequality sign for making a judgment. But for the calculation part, you will treat them as equal to. Okay? Because when you have something greater, let's say somebody says x plus 3 is greater than 7. What does it mean? That x is greater than 7 minus 3. So x is greater than 4. So now 5, be it 5, be it 6, be it 7, be it 8. Those are the answers, and you can go on. Here in this case, what did I do? I did not deal with or did not worry about this thing till I got to this point. Once I got this one, now I can make a judgment that yes, x has to be greater than 4. That means it could be 5, 6, 7, 8, 9, 10. Right?
So inequality gives you multiple answers. Equal to gives you exact answer, right? So here when you have to deal with this, you always assume that there is no inequality that exists. So your calculation purpose, you will say, okay, fine, this is greater than or equal to 20, I will treat this as 20. If this is this, I will treat this as equal to. And then I will have two equations to deal with. So here y equals 20 minus x. Or since we are trying to solve for y, I will say x equals 20 minus y from the first equation, and then I will substitute this value in the second equation. Okay, so 50x, instead of x I will say 20 minus y plus 80y equals 1500. Yeah, so this becomes 1000 minus 50y plus 80y equals 1500. This makes it 30y positive plus 1000 equals 1500. So 30y equals 1500 minus 1000 equals 500. So y equals 500 by 30. This is 16.6666 and so on. Yeah. So I got value of y is 16.66. Now, since I cannot have partial boxes, I will do the rounding to the nearest possible whole number, which is smaller than this number. Okay, because more the number here, you will reach the threshold, right? So I will go with, okay, I got 16.66. Let me use 16. Let's put 16. I mean, you cannot go wrong here actually. You use 16 and then you will anyways put it here to see if the equation is valid or not. Okay. So let's go with 16. 16.66. I will ignore one decimal part. I'll go with the whole number. 16. Okay. If y is 16, what will be the value of x? 4. 20 minus y. That is this. 4. So this is probably my borderline case because this is greater than or equal to, this is less than or equal to. So equal to is common in both the equations. So whatever I am getting here, this is my borderline case. This is the minimum number of boxes that we are supposed to have and that we are meeting. Only validation I would want to do is, let's see if I go with 16, 18 pound boxes and 4 50 pound boxes, am I within this limit or not? Yeah. So if I do that, so 50 into 4 plus 80 into 16. Let's see what is the value here. This is 200. 16 into 8 is 128 into 0. Sorry, 128 and 0. This makes it 1480. So the time I go beyond 16, this criteria will not be met. Okay, because if I go 17, this will be more than 1500. Because 17, I have to have at least 3 here. See, now let's check. 17 into 80. 6, 8 plus 5, 13. Okay, plus 3 boxes of 15. That is 1510. Okay. So this is, so basically what the summary here is, when you have two equations to deal with inequality, assume it to be equal, find out the solution, and that becomes your borderline case. That is your borderline case, which you will use for validating here. Once you got y equals 16.66 and you know that you cannot go beyond this, the time you go beyond this. So, I mean, if you look at exact math, it will be like, okay, this many boxes of 18 pounds, 80 pounds, this many boxes of 50 pounds. And you cannot have partial boxes. So you have to look for the number smaller than this, because if you go 17, you are crossing the limit. If you go below this, you are still within the limit. Okay.
Okay. I kind of took you to all the possible places to solve this. But there is a better way of solving it also.
So, summary of what we have done today, when we are dealing with inequalities, treat them as equal to and then solve it and then find out the borderline case, and based on that you can do the calculation. Okay?
It's already there.
Okay. Now, there is another way of solving these kind of sums.
Have you dealt with graphs before? So say our equation was x plus y is greater than or equal to 20. Second equation was 50x plus 80y is less than or equal to 1500.
Guys, have a seat. No making noise. Let me finish this class and then we'll start. Okay? So when we have this kind of thing to deal with.
Now, if I try solving this one, x plus y is 20. Let's try plotting this graph for x plus y is greater than or equal to 20. Let's plot it for x plus y equals 20. What happens? If let's say x is 0, what will be the value of y? 20. So if x is 0, y is 20. This is my first point. When y is 0, what is the value of x? When y is 0, value of x is this. So this becomes my this graph. Now, when I am saying x plus y is greater than 20, if you pick up any point below this line, here, you will find that this is less than 20. If you have to go above, you have to go, so your one side of the equation is somewhere here. Okay? Now what you will do, 15x plus 80y is less than 1500. If we try plotting this one, okay, this will be something like this.
I'm just making it up.
Okay? Then what happens is your solution, see, this line says, but this one, all this are falling here. This is less than this thing. So it will be below this. Okay? So basically, whatever is the intersection, you will say all my answers are lying in this range actually. So that is how we were getting that, okay, x plus y is this one. We will probably
We'll look at the logarithms tomorrow first,
and then if time permits,
we'll try plotting this graph. I'm doing it in a hurry and I know I'm not convinced about explaining this. Okay, so we'll do this tomorrow and then we will